There are two basic input configurations for a two-channel amplifier, stereo and parallel mono. Stereo mode implies that each channel will receive a different input signal. In parallel mode, each amplifier channel receives the signal connected to input 1. Parallel mode eliminates the need for Y cords and adapters when a common signal is required to feed both amplifier channels. There are also two basic output configurations for a two-channel amplifier, stereo and bridged mono. In stereo mode, the amplifier has two output channels, each working independent of the other. In bridged mono mode, the two channels become a push-pull configuration and thus combine into one high-power output. Proper settings are critical to the amplifier operation. Before the amplifier is energized, the user should select the correct configuration mode, stereo, parallel, or bridged mono. Prior to energizing the amplifier, the control knob should be set to 0. Once the configuration settings are set, the loudspeaker cable should be tested for shorts. This can be checked with a speaker tester or basic volt-ohm meter. An easy way to set the amplifier control knobs is to play a CD or music source through the mixer with the faders and controls set to nominal or unity gain. Turn the amplifier controls up until the desired system volume is met. Listen to the music and ensure no distortion or clipping is occurring, especially at high levels. Leave the amplifier controls at that setting, and then adjust all volumes at the mixing console. This will ensure an acceptable gain structure, preventing clipping and distortion. There are three main causes of clipping and distortion: pushing an amplifier beyond its rated output, overpowering the loudspeakers, or sending a distorted signal to the amplifier. This normally occurs when you want more volume and the amplifier is already working at full output. Overdriving the amplifier will clip the output signal, causing the loudspeaker to distort. This will cause amplifier malfunction and possible loudspeaker damage. Clipping is easily detected when critical listening is practiced by the audio systems engineer. The amount of heat generated by power amplifiers can be quite immense. Proper ventilation around the amplifier and conditioning of the room where the amplifiers are located is critical. Overheating greatly decreases the lifespan of the amplifier. Most manufacturers provide specifications and guidelines for proper heat dissipation. Amplifiers require large amounts of clean AC power. High-power amplifiers require their own 120-volt, 20-amp circuit, while medium-power amplifiers can normally be paired on one 20-amp circuit. Remember, the power amplifier is dependent on the AC power source to produce the power it was designed to deliver. If the AC source is not clean, or if proper grounding is not implemented, buzz and hum will make their way into the audio system. It is recommended that a power conditioner be placed in front of all amplifiers. Power conditioners maintain constant voltage levels and offer sequential powering so that each piece of equipment can be powered in sequence, which helps prevent damage to audio system components. The process of selecting an amplifier begins by determining the power handling of the loudspeaker you want to drive. In the case of an MD-F122 loudspeaker, 400 watts RMS at 8 ohms. Naturally, one would select a 400-watt amplifier to power this loudspeaker, but this is not necessarily correct. In reality, you would want to use an amplifier that will produce up to 800 watts at 8 ohms, which would provide 3 dB of headroom. A little-known fact is that the main cause of loudspeaker damage is using an amplifier with too little power, not too much. If an amplifier is overdriven and is clipping the output signal, DC power is transmitted across the loudspeaker inputs, potentially damaging the speaker drivers in the process. Many amplifiers include additional features, including DSP input modules, network control and monitoring, output sequencing, and hibernation modes. These features are all intended to make the sound engineer's life easier by allowing extra control and the ability to monitor the amplifier's performance visually by a computer in the sound booth. These features also increase the amplifier's longevity with increased lifespans. A power amplifier is an electronic device that increases the line-level audio signal to loudspeaker level. Power amplifiers differ by way of their class, power rating, and number of channels. An amplifier's output is dependent on the impedance load of loudspeakers connected to the output and the input voltage level. There are two basic input configurations for amplifiers, stereo and parallel mono. There are also two basic output configurations for amplifiers, stereo and bridged mono. Before the amplifier is energized, the user should select the correct configuration mode, stereo, parallel, or bridged mono, and check the loudspeaker lines for shorts. Amplifiers generate heat, and care should be taken to ensure proper ventilation around the amplifier. Amplifiers are dependent on their required AC power in order to produce the output they are designed to deliver.